Good morning, everybody. Welcome. Let's continue with our section on transportation management. And in the last lectures, we talked about general design issues related to transportation. Today, I would like to go deeper into this topic and try to show you a first approach how to model a problem related to transportation management. And the topic of today's lecture is the transportation problem. Please be aware that this does not mean we are looking at any kind of transportation problem. This is a specific term which is used for characterizing one specific type of problem with a specific structure, and this term is used in the operations research community. So if you talk to a practitioner about the transportation problem, he might have a completely different understanding. Though, however, this is a specific term used in the operations research community describing a well-defined problem. Keep this in mind, please. Today's learning goals are the following. Because the transportation problem is a very specific problem, you should be able to explain exactly what the transportation problem is and what it is not. You should know some basic structures of model building, of mathematical model building. Namely, you should know the differences between an objective function, a constraint, a decision variable, a feasible solution, and an infeasible solution. You should be able to create a model of the transportation problem for simple real-world cases, and you are able to use the Excel solver to solve the transportation problem. Let's start. Today's lecture is supported by the textbook of Namias and Olsen, in particular the chapter 6.3 and 6.4. You find both on the Moodle course. This book is in our library, but as you cannot access it, I will put it on the Moodle course. Let's start with an example. We look at the transportation of processed fish to deep freeze warehouses. As you know, fish production is beyond oil a very important sector in Oman. In 2017, we produced almost 350,000 tons, and almost 180,000 tons were exported to other countries. Our ministry tries to build an integrated value chain to boost the exports from our sea products to international markets, so that we are able to provide our fish to international customers like Korea or Japan, from the point of getting them out of the sea to delivery in less than 36 hours. What is the general process? Roughly speaking, first of all, we have to harvest the fish, we have to do the fishing. These might happen on smaller fishing boats or more bigger industrialized fishing boats. After the harvesting, we deliver the fish to some factory. Sometimes the fish is already processed on industrialized ships, but let's look at this example on processing the fish, the harvested fish in a factory. We clean the fish, we sort the fish, maybe we have the complete fish, or maybe we start cutting the fish, removing some parts that are no longer necessary. So some processing happens in the fish processing factory. We do some quality inspections maybe to decide on what kind of quality the fish is and what price we can charge for it. From the factory, we need to transport the fish to our markets. Maybe it's possible for retail customers to buy fish at the factory, but this is not the common way of selling the fish. Most of the fish is sold at retailers like Carrefour or Lulu or designated fish markets. So now we look at the example of bringing the fish from the factory to our retailers. This is a part of this value chain that we want to look at. And our example company is called Salma Fishery, and Salma Fishery supplies fish to 4 deep freeze warehouses operated by retailers. Salma Fishery agreed to supply the warehouses with the following proportion of its total fish production. We supply Lulu, Balka Fish Market, Carrefour and Matra Fish Market. These are our customers. In particular, more specifically, these are the deep freeze warehouses of our customers that receive the fish from our factories. And now the contract is defined as follows. 18% of our production is delivered to Carrefour. We could also have a contract for a specific amount of fish, for example, a specific number of tons, but depending on the season, this might create a problem if the season is good or less good. So here we agreed on a percentage of our production. We applied some kind of forecasting model based on historical data, and we expect that Salma Fishery will produce around 261 cases of fish in one day. And this is our production for a single day. This is our total production, and the production happens in 3 different factories with 45 cases in factory 1, 121 cases in factory 2 and 95 cases in factory 3. So given the percentages and the total number of cases, this means that we have to provide Lulu with 31% of our production of 261 cases. This is roughly 81 cases. In this example, in this case, of course, we are only dealing with integer numbers. It does not make sense here to write 81.5 cases, because we will only deliver them with full cases for sake of simplicity. It's more effort to pack a half a case or a third of a case and deliver it. We only deal with full cases, and these are the delivery quantities. Now, the mode of transportation here is road transportation. We use a truck, a plane, and these things, or a train, for this example, would not make sense. Though the mode of operation is that one of our trucks picks up our products at the warehouse, then we drive to the deep freeze warehouse of our customer, and the empty truck drives back. Now the question that we want to answer, the challenge that we want to solve: how many cases of fish should be transported from which fish processing factory to which deep freeze warehouse? How shall we organize the transport? In order to decide this, we need to develop some ideas about the shipping costs. What are the transport costs? So in this table I gave you some example transport costs. For example, from the factory F3 to our customer A, which is Lulu in that case, transporting a single case of fish costs 1.550 reals, 1,550 besa. Transporting from factory F1 to customer number C costs us 380 besa. Why are the prices different of transporting a case of fish? Of course, the prices mainly depend on the distance between a factory and a warehouse. This is the main cost driver, though it appears that the distance between F3 and D3 is quite high, at least compared to the distance between F1 to D. Though factory F1 seems to be closer to our customer D. Well, these are the prices. Now let's try to visualize the problem. On the left side, visualizing the problem is always good to learn more about the problem, to understand the structure of the problem. So on the left side, I have drawn you the three factories, F1, 2 and 3, and I wrote the number of cases of fish that they produce each day. Now this drawing represents the situation of a single day. On the right side, I have drawn you the deep freeze warehouses as rectangles in green, and I have drawn you the demand of each warehouse in the number of cases. So the Barca fish market B requires 78 cases each day. Now we need to add the cost to this drawing. Transporting from factory 1 to Lulu costs us 250 besa. From F1 to Barca fish market is 420 besa. These are the cost numbers given in the previous table. I write these cost numbers. This is the cost data from factory F1, and now we add it for factory F2 and F3. So this gives a complete overview of our data, and now the challenge is to decide where should these 45 cases that are available in F1 go to. Shall we provide them to Lulu, Barca fish market, Carrefour? For example, if we bring everything to Carrefour, then the demand at Carrefour is almost covered, but 2 cases are still open. Or shall we split the different cases to all the 4 customers? What shall we do? So deciding how many cases shall be transported from which factory to which customer, so that the demand of all the customers is completely fulfilled. This is the structure of the transportation problem.